Good morning, students. Welcome back to new session. In this session, we are going to discuss about decimal expansion of a number. So, a decimal expansion of number can be two types. One is terminating decimal and non-terminating decimal. When it is non-terminating decimal, it will be either repeating or non-repeating. Now, we have two kinds of numbers in real numbers, that is rational and irrational. Now, for a rational, it will be either terminating or non-terminating repeating decimal, and for irrational, it will be non-terminating and non-repeating decimal. You can see the flowchart of this. You can know why it is rationals have and how you can say it is irrational. When you think about terminating repeating decimal, it can be converted into fraction, so it is called as rational. When you take non-terminating decimal, it cannot be converted as fraction, so it is called as irrational number. Now, definition of terminating decimal. The word terminate means end. A decimal that ends is a terminating decimal. In other words, a terminating decimal does not keep going. A terminating decimal will have a finite number of digits after the decimal point. Examples of terminating decimal, you can see here 27 by 24. It terminates it. The decimal expansion is 1.125. Similarly, 3 by 4 is 0.75, 8 by 10 is 0.8, 5 by 4 is 1.25, 25 by 16 is 1.5625. Case 2, the remainder becomes not zero or called non-terminating decimals. So repeating decimals are decimals that contain an infinite number of digits. While expressing a fraction into a decimal by the division method, if the division process continues indefinitely and zero remainder is never obtained, then such a decimals is called non-terminating decimals. You can see an example. 1 by 3 if I divide, I got 0.333. It's repeating and the remainder is not terminated. It is 1. It does not ends with 0. You can see one examples, 0.76923. Based on this concept, we have some exercise 1.3. Write the following in decimal form and say that kind of decimal expansion each has. You can see the first one is 0.36. So when you see 0.36, it is terminating decimal. The next one is 0.090909. This is non-terminating decimal. This is terminating decimal. The other one non-terminating decimal. The next one also non-terminating decimal. And the last one is terminating decimal. You can check down with the division method, expansion and all. You know that 0.142857, can you predict what the decimal expansion of? Now it is root 7 actually. So what is the decimal? It's 1 by 7. 1 by 7 equal to 0.142857. What is the decimal expansion of 2 by 7, 3 by 7, 4 by 7, 5 by 7, 6 by 7 without actually dividing? When you take 2 by 7, you can write as 2 into 1 by 7, which can be written in the form of 0.285714 bar 2 h. So you can check it practically. 6 by 7 also can be written as 6 into 1 by 7. So we will get approximate 0.857142 bar. Express the following in the form of P by Q, where P and Q are integers and Q is not equal to 0. You can take 0.6 bar, 0.47 bar. Now first question, if you see, we are going to make the decimal expansion of this 0.6 bar is 0.6666 and all. Now here you are going to multiply the equation with 10. You will get 10x equal to 6.666 and so on. Here, why we are multiplying with 10? Because the repeated term is 1. The repeated term is 1. So you are multiplying with 10. You will get 6.666. If the repeated terms are 2, you are multiplying with 100. So since there is bar over only 6, so we are multiplying with 10. So when you subtract first equation from second equation, you will get 9x equal to 6 and x equal to 6 by 9. 6 by 9, or simplest form you can take it as 2 by 3. 2 by 3. Okay, 6 by 9 or 2 by 3. Similarly, when you go for 0.47, 7 bar is only for 7. Since there is one repeating digit after the decimal point, so multiply 10 on both sides, we get a 10x equal to 4.7777 all. Yes, you should subtract 1 from 2, you will get 9x equal to 4.3 or x equal to 43 by 90. So the P by Q form of 0.47 bar for 7 is 43 by 90. So please go on with express the following in a form of P by Q: 0.001 bar, 2.356 bar. So express 0.999, that is bar to 9, in the form of P by Q. Are you surprised by your answer? Which your teacher in class may discuss why the answer makes sense. Now you can see, if you express 0.9 bar in a P by Q form, you will get 1. So by doing this, you will get 1. Why so? Because 0.9999 is the nearest number to 1. The P by Q form will be 1. That is to the nearest. Got it? So it is near to 1. So almost 1. So 0.9 bar is nothing but almost. You are going to add 0.00001 to this 0.99. You will get 1. So that is the reason 0.9 bar, when you take as a P by Q form, it looks like 1. What can the maximum number of digits be in the repeating block of digits in the decimal expansion of 1 by 17? Perform the division to check your answer. You can see there are 16 digits in the repeating block of the decimal expansion of 1 by 17. So you can see 0.05888235294117647. Again it starts with 0. Again you will get 100. After, see, you will get 1 after 120 minus 190, you will get 1. Again you are taking 0, you will get 100. So again it repeats from 0.05888235294117647. So 16 digits are repeated block in this 1 by 17. So look at several examples of rational numbers in a form P by Q, where P and Q are integers with no common factors other than 1 and having terminating decimal expansions. Representation. Can you guess what property Q must satisfy? Now you can see, if you want to derive this question answer, in the previous example, if I am dividing with 2 or dividing with 5 or dividing with multiple of 2 and 5 only, then the decimal expansion is terminating. We observe that Q is 2, 4, 5, 8, 10, then the decimal expansion is terminating. For example, 1 by 2, you got 0.5. 7 by 8, you got 0.875. 4 by 5, you got 0.8. The denominators are in a form of 2 power n or 5 power m or both 2 power n and 5 power m. Then the decimal expansion will be terminated. We can observe that the terminating decimal may be obtained in the situation where prime factorization of the denominator of the given fractions has the power of only 2 or only 5 or both. Thank you, students. That's all for today.